Hello grade 9 learners, have a nice day. Welcome back to my channel. For today's video, I'll be discussing to you about direct variation. After watching this video, you will be able to answer the following questions. First, how to determine direct variation. Second, how to translate direct variation statement. And last, how to solve worded problems involving direct variation. Let us describe first what is direct variation. We can say that there is direct variation whenever a situation produces pairs of numbers in which the ratio is constant. This will be explained further in the next slide. Next, the statements y varies directly as x, or y is directly proportional to x, y is proportional to x, may be translated mathematically as y is equal to kx, where k is the constant of variation. So meaning to say, the three statements have the same translation, which is equal to y is equal to kx. Next, for two quantities x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. That is direct variation. And last, the graph of a direct variation is a straight line with a positive slope, or a line that rises from left to right. Remember, straight line when it comes to the graph of direct variation. Now let's have example. Real life example of direct variation. A motorist drives along the Davao Surigao Road at a constant speed of 60 kilometers per hour. The distance traveled by the motorist and the period of time spent are shown in the table below. So we have here a table of values. The first row is the value for time in terms of hours. So we have here 1 hour, 2 hours, 3, 4, and 5. The distance in terms of kilometers, so we have here 60. So for 1 hour travel, the driver covers 60 kilometers. 120 for 2 hours, 180 for 3 hours, 240 for 4 hours, and 300 for 5 hours. If you have observed, as the number of time increases, the number of distance that is being covered also increases. This is what we call direct variation. An increase in one variable, say for example the variable of time, causes also an increase in the distance covered. Okay? This is an example of direct variation. The ratio between the distance traveled and the time spent is constant. By the way, if you don't have the worded problem, you are only given the table of values. How will we know that it is direct variation? Okay, you will know that the table of values is direct variation if the ratio between the two variables is constant. So in here we have the distance traveled and the time. Now let us try to check the ratio between the distance traveled and the time spent. Okay, by ratio, that is the distance traveled, let us denote it with d, and the time spent is letter t. So we have ratio is equal to d over t. So we have here in the first column RR is equal to, distance is 60, time is 1. So 60 divided by 1 is 60. For the second column, distance traveled is 120 and the time is 2. So if we're going to divide 120 divided by 2, that is equal also to 60. For the third column, the distance traveled is 180. The time spent is 3 hours. So 180 divided by 3, that is also equal to 60. Next, 240 divided by 4, that is also equal to 60. And on the fifth column, we have 300, the distance traveled within 5 hours. So 300 divided by 5 is equal to 60. So if you have observed, the ratio is constant. So if you will be given a table of values, tabular form, you just check the ratio. If the ratio is constant, then the table of values is showing the values for the direct variation. So here we can also denote the ratio. Okay, we have here 60:1. So we can now form a proportion. 60:1, we have here 60:1 is equal to 120:2. Now if we're going to multiply the means, this one, 1 and 20 is what we call the means. The product for this is equal to 120. 1 times 120, that is equal to 120. And on the other hand, if we're going to multiply the extremes, 60 and 2 are what we call the extremes. If we're going to multiply this will also give the same answer. 60 times 2 is also 120. So that is the characteristic of direct variation. Now let's solve a problem. Before that, always remember the statements y varies directly as x, or y is directly proportional to x, y is proportional to x, is translated as y is equal to kx, where k is the constant of variation. Remember that the three statements are just have the same translation. Now let's begin with the first example. The cost C of meat varies directly as the number N of kilos bought. So since the cost of meat is being denoted by C and the number of kilos bought is denoted by N, we will be using the variable being assigned. So if once we're going to translate this will be translated as C equals KN. Cost, that is C, is equal to, varies directly, do not forget to write the variable K. This is the constant of variation. And the number of kilos bought, we have N. This is the translation. Another example. The mass of an athlete varies directly to its height. Since the mass is being denoted by M, so we will have M is equal to KH. Third example. The distance D you travel is directly proportional to the time T you have been traveling. So this is translated as D is equal to KT. Last example for translation. A person's annual salary S is directly proportional to the number of years Y he or she has spent in school. And this is translated as S is equal to KY. Now let's have a problem solving involving direct variation. Number 1. If y varies directly as x and y is equal to 12 when x is equal to 4, find y when x is equal to 12. Okay, first we have to solve for our k, but before we can solve for our k, we have to translate first the given equation. Remember that there are times that the variable being used may vary. So just follow what is the variable being given. So here we have y varies directly as x. So this is the translation. Now we have to solve for our k. Y is equal to 12 and x is equal to 4. This is 4. Now 12 is equal to 4k. To solve for k, we have to divide both sides of the equation by 4. So we have 4k divided by 4, that is equal to k, and 12 divided by 4, that is equal to 3. So we have now a value k is equal to 3. Next, solve for y. We will be using the same equation, y equals kx. This time, let's substitute our k by 3. And for our x, we have 12. So 3 times 12, that is equal to 36. This is now the value of y when x is equal to 12. For the second example, if y varies directly as x and y is equal to 30 when x is equal to 5, find x when y is equal to 90. In here, we are asked to find the value of x. So same process, we have to translate. So we have y is equal to kx. Substitute our y here with 30 and our x is 5. Now we have 30 is equal to 5k. Divide both sides of the equation by 5. So we have 30 divided by 5, that is equal to 6. So k is equal to 6. Next, substitute this value to y equals kx and solve for x. So y is equal to 90, our k is 6, and we are going to solve for x. So 90 is equal to 6x. To solve for x, divide both sides of the equation by 6. So 6x divided by 6, that is equal to x, and 90 divided by 6, that is equal to 15. So therefore, the value of x is equal to 15. Another example. Find the constant of variation in which y varies directly as x and y is equal to 28 when x equals 2. Since we're asked to find the constant of variation, it refers to the value of k. So we have here the translation, y is equal to kx. Now let's substitute. Y is 28 when x is equal to 2. So to solve for k, we have to divide both sides of the equation by 2. So 2k divided by 2, that is equal to k, and 28 divided by 2, that is equal to 14. So the constant of variation is equal to 14. Next problem. Age's income varies directly as the number of days that she works. She earned 3,000 for working 12 days. How much she will earn if she will work for 20 days? Okay, first we have to assign a variable that will represent for the unknown. Okay, so let I is equal to Age's income and D, the number of days that she works. Now, we have to translate. Age's income, I, is equal to, varies directly, we have K, to the number of days, we have D. So this is the equation. Now we have to solve for K. So by substitution, we have 3,000 and the value of D is 12. So solving for K, 3,000, that is equal to 12K. Divide both sides by 12. So 12K divided by 12, that is equal to K. And 3,000 divided by 12, that is equal to 250. So we have now the value of K, which is 250. Next, we have to solve for I when D is equal to 20. We will be using the same equation. I equals KD. Now, let's substitute. Our K is 250 and our D this time is 20. So 250 times 20, that is equal to 5,000. So therefore, AJ will earn 5,000 pesos if she will work for 20 days. Another example, the weight of an object on Earth varies directly as the weight of the same object on the Moon. A 60-kilogram man on Earth would approximately weigh 10 kilogram on the Moon. How much would a 70-kilogram man weigh on the Moon? Okay, for our solution, we have to assign again a variable. So we let E, weight of an object on Earth, M, weight of an object on Moon. Now let's translate the equation. So we have here the weight of an object on Earth varies directly as the weight of the same object on the Moon. Now let's substitute. So the man is weighing 60 kilogram on Earth. Then that is equal to 10 kilogram on the Moon. Now let's solve for K. So we have 10K, that is equal to 60. To solve for K, divide both sides of the equation by K. So 10K divided by 10, that is equal to K. And 60 divided by 10, that is equal to 6. So we have now the value for the constant of variation. Now let's solve for the value of M. Okay, the same equation. So we have here 70, the weight of the man on Earth. And then we have the constant of variation K, which is 6. Then multiplied by M. Or that is just equal to 70, that is equal to 6M. Next, solve for M. 6M divided by 6, that is equal to M. And 70 divided by 6, that is equal to 11.67. So it means that a 60 kilogram man on Earth would approximately weigh 11.67 kilogram on the Moon. Next problem. If 54 kilogram of rice can feed a family for 45 days, how many kilograms of rice are needed to feed the same family for 70 days? This is also a direct variation problem. Okay, let R be the number of kilogram of rice to feed a family. The number of days needed to feed the family. So, translate the statement. So we have rice, number of kilogram of rice to feed a family that varies directly to the number of days. Now let's solve for K. So R is equal to 54 and D is equal to 45. So 54, K times 45 is 45K. Solve for K, so we have 45 divided by 45, and that is equal to K. Next, 54 divided by 45, that is equal to 1.2. So K is equal to 1.2. Now let's solve for R. So same equation. So our K is 1.2, and this time we will be using 70 for the value of our D. Multiply 1.2 times 70, that is equal to 84. So it means that 84 kilograms of rice are needed to feed the same family for 70 days. Now, for our last problem, this is the example that I had given in the previous slide. So a motorist drives along the Davao-Surigao Road at a constant speed of 60 kilometers per hour. The distance traveled by the motorist and the period of time spent are shown in the table below. So the question here is, write an equation showing the relationship between the distance and time. B, how far the motorist traveled after 8 hours. So for A, this is the equation showing the relationship between distance and time. But how did we get this one? So the distance here varies directly as time. So we have to denote D for distance and T for time. So our equation is D is equal to KT. Next, we have to choose a pair of values. You can choose a pair, either 1 or 60, 2 or 120, or 3 or 180, but this time I make use the pair of 1 and 60. So when the distance is 60, our T is 1. So we have 60 is equal to K times 1. Simplify, so we have 60 is equal to K. So we have now the value of K, which is equal to 60. Now go back to our equation. D equals KT. Substitute the value of K, which is 60. So we have D is equal to 60T. This is now the equation showing the relationship between distance and time. And for question B, if T is equal to 8 hours, how far the motorist traveled? So we have already the equation, which is D is equal to 60T. Let's just substitute this time T by 8. So 60 times 8, that is equal to 480. So it means that the motorist traveled 480 kilometers after 8 hours. Thank you so much for watching, guys. If you learned something, kindly like. And if you have questions regarding the video, just comment it in the comment box. Don't forget to share to other students for them to learn or master the lesson. And please don't forget to subscribe to be updated for more math lesson videos and turn on the bell for notifications. Before I end, let me share to one of the verses from the Bible. Blessed are the pure in heart, for they shall see God. Matthew 5 verse 8. That's all for today, and God bless you all.